So this is the fourth time I'm doing this video now, because the first time my microphone was connected incorrectly, so you couldn't hear anything. The second time my camera wasn't recording. The third time my iPad was super buggy. So hopefully fourth time's the charm. If I sound very sick and tired of doing these questions, it's because I've done them 4 times already. So just keep that in mind. Anyway, hey, how's it going? Hope you're doing well. Today we're going to be going through the mathematics component of the John Monash entrance exam. We're going to be going through 5 specific questions that I think are quite valuable for you. And I'm going to be really emphasizing the fact that the maths component isn't about how much content you know or how well you know it. It's more about how quickly you can actually get to the final answer. Because at the end of the day, every single question is weighted the same. So a question that takes a long time to do with many steps is the same as a question that you can do in your head, which is a part of the game that you have to play. So a lot of people don't really realize this, and they go in with the idea like, oh, I'm going to get every single question done. Mostly unrealistic for a lot of people. And some students go, I'm only going to get half the questions done and I'm going to spend a minute on each question, which is also quite unrealistic. So a lot of people say that the average time for a question is 30 seconds a question, but keep in mind that that's the idealistic time. So that's the time where if you had a perfect exam, you would spend 30 seconds on every single question and then finish it by the 30-minute mark. However, you're not going to get an ideal exam. You're probably going to get some questions that'll take a minute or two and some questions that'll take like 4 seconds, 5 seconds to answer. So in today's video, I'm going to be going through some fundamental techniques that you should be aware of to help you build speed. And we'll walk through them in depth, and I want you to have a crack at it as well in your own time. So let's just jump right into it. So this is the first question. What I want you to do is I want you to pause, take a moment to actually solve it yourself, and then when you're ready, unpause and we can go through it together. Okay, how do we go? So this one is relatively straightforward. All you really have to do is count how many dots are in a triangle. What I always like to do is I always like to write these out as a table or as a sequence. So we know that the first term has 3 dots, the second term has 6 dots, and the fourth term has 9 dots. Okay, you can count each one of these or you can recognize the pattern instantly. What you can notice is 3, 6, 9. Each one of these are increasing by a factor of 3, or they're adding 3 to each one. So that means that the pattern for this is just 3 times whatever number triangle you have, where n is the number of triangle. So if you wanted to solve for the 10th triangle, all you would do is sub in 10. You'd end up getting 30. Okay, I might actually start writing it in blue because I feel like black is a little bit hard to read at times. So I'll write it in blue from now on. But that's how you go about doing this question. My advice is always try and either find the pattern based off of the geometry or find the pattern based off of the sequence. So it'll be helpful if you guys understand how sequences and series work and how you can use sequences and series to figure out solutions to these questions. So that's one way you can do it. The other way is you can just use the umbrella method that I like. That's just the way I like to do things. So yeah. Anyway, moving on to question 2. Have a crack at this one. And then when you're ready, unpause me and we will go through it together. All right, how do we go? Let's go through this one together. So here we need to find the angle x, and we're given a couple of triangles and a trapezium. So one of the things we can do in this question is we can just recognize that, yes, okay, cool. I know that this is an equilateral triangle. So I know each one of these angles has to be 60 degrees. Okay. Then what you can recognize is you can recognize that, hey, this is just a flat line. And this angle, based off of symmetry on a trapezium and this triangle here, has to be identical to my angle x. So what you end up getting is you end up getting 2x plus 60 degrees is equal to a flat line 180. Solve for x. You get x is equal to 60. Okay, so that's the quickest way to go about doing this. You can probably do this in your head as well if you see this. Another way you can do this is, instead of understanding this, what you can do instead is you can find the angle of this value here. So you can do 60 plus y is equal to 180 degrees. And then you can get y is equal to 120. And then you can use the fact that in a trapezium, this angle here and this angle here have to add up to 180 degrees. Or alternatively, what you can do is based off symmetry, you can say that this angle here is the same as this angle here. And then you can use the quadrilateral rules, which is 360 degrees is the sum of all interior angles in a quadrilateral, and then solve it that way. So there's multiple different methods to go about solving this. And when you're doing questions, I don't want you to just do one question and go, that's the only way you can do the question. I want you to try and see if there's other ways you can solve the problem that maybe require different bits of information. Because if the question was slightly different, if we had like an unknown angle y here and then like some unknown angle z, you wouldn't actually be able to solve it with just the technique that we used here. So you would need to find other ways to go about solving this, because it might be a little bit more annoying to solve it otherwise. Okay, so just keep that in mind when you are doing questions like this, where you should always try and look for other methods of solving it that require other bits of information or just other techniques as well. Mathematics is mainly about the most optimal solution, but if you can find other solutions as well, you can pick and choose which one is the most optimal. So just keep that in mind when you're doing questions, okay? Moving on. So have a read of this and give it a crack. All right, how do we go? Let's go through this one together. So we're given the fact that we have a 15% off sale in the music store, and we thought that Sarah buys something labeled at $30.99 before the discount, and then something that is normally $4.95. What this tells me is that this $4.95 is included in the discount as well. It's implied that it's included in the discount. So what I'm going to do instead is, once I recognize that, I'm going to actually look at the answers that I have, and I'm going to see how far away each one of these values are. And I can see they're roughly $2 away from each other. So I know that if I change my numbers by a couple of cents, I'm probably not going to have a significant variation that'll give me a completely different answer. So instead of saying $30.99 and doing the math with $30.99, what I'm going to say is I'm going to say this actually becomes $31. And I'm going to say this $4.95 becomes $5. So I'm just going to round it to the closest dollar. And all I'm doing is changing this by 5 cents, changing this by 1 cent. So it doesn't really change much. Key thing here is that I have 2 posters. So I need to multiply this by 2, which means that this actually becomes $10. Okay. Now, the question asked me, what is the price she will need to pay at the register? So what's the actual final price she has to pay? So all I need to do now is recognize that 15% off just means 85% of the original. Okay, so it just means 85% of the original price. So what I can do is I can go, okay, well, if I just add both of these two together, because both of them are in the same discount, I can do $31 added with $10, which gives me $41. And then all I need to do is I just need to find what 85% of this is. So this is going to give me 41 multiplied by 0.85, which is the same as me saying 41 multiplied by 85 all divided by 100, which personally I think is easier to calculate. If you're not sure how to calculate these quickly, my suggestion is that you actually go on YouTube and you look at how to multiply numbers quickly, how to square root numbers quickly, how to square numbers quickly, and find techniques to do that, because these calculations come up quite a lot in almost every single type of question that you get. So it's important that you identify methods to calculate them really, really fast. So the more tools you have in your arsenal, the more tools you have in your arsenal, the better off you are. So just keep that in mind. Anyway, when you multiply these together, you should end up getting $34.85 divided by 100, which is the same as me saying $34.85, because when you divide by 100, you just move the decimal point across. Okay, so that's what I end up getting. I look at the answers and I see that none of them are $34.85, which makes sense because I shouldn't get that, because I've done some approximations in my calculations. So I'm just going to look for the closest one. Closest one is option B. Okay, and that's all there is in this question there. So hopefully that makes sense. Again, key takeaways is when you're rounding and approximating, make sure that you look at the answers first and see if it's feasible for you to do that. If you had a gap of like 10 cents in here, then I wouldn't actually round it, and I might actually end up skipping the question because the mathematics for $30.99 and $4.95 are quite like arduous and specific. So I actually wouldn't end up doing this question. I might like do my best guess and then flag it to come back for later. But it's up to you what you decide to do. Obviously, if you're much more numerically inclined than what I am, then you can definitely have a crack at this question. But personally, I just would skip it if it didn't have any like big gaps. Okay, so if this was like a 10-cent gap or a 3-cent gap or something like that, then I probably wouldn't do this question. So just keep that in mind. Okay, let's have a crack at this one. This one's a fun one. Try and get it as quick as you can. All right, how did we go? So hopefully you were able to get this relatively quickly. If you were someone who calculated this like fully, I would suggest that again, you look at the answers and you kind of see what is going on in the question. So here I noticed that every single one of these terms is negative. Every single one of them, except for this last one. So I could either pick the answer straight away or I could isolate it down to 3, right? So let's take a look at the question itself. What are we doing? Well, it's just a series of additions and subtractions. So if I had to take 2.00 whatever it was, added it with 2.42, I end up getting 4.42 something, right? Then what am I doing? Well, I'm subtracting 4.02 from this. So I always end up getting a positive 0.4, or in other words, because this positive number that I end up with is bigger than this negative number, this will always be some positive value. So I know for a fact that this has to be my right answer. And you can probably get this in about 10 to 5 seconds, right? It's just a matter of recognizing the patterns and recognizing when you can and can't do things. So this is a really simple question, but if you were someone who actually spent the time to do it, then just keep in mind that you have the answers. You just need to pick what the best one is. Okay, so just keep that in mind. Moving on to the last one that we'll do today. It's going to be question 5. So have a look at it. Keep everything that we've done in mind, and we'll go through it together. Okay, how do we go? Hopefully you got the answer. Let's go through it together. So what I'm going to notice is every single one of these solutions is off by a factor of 10. So as long as I don't overextend by a factor of 10 when I'm rounding my numbers, I should still be in the right region, in the right ballpark. Okay? So all I'm going to do is I'm going to round this to the closest factor of 10, which in this case is 50. Going to round this to the closest factor of 10, which in this case is 0.1. Going to divide this by its closest factor of 10, which is 0.005. Then I'm going to solve this. So this is going to give me 5 in the numerator divided by 0.005. You can write this as a decimal or as a fraction if you're not the most confident. So you can say this is divide by 5 divided by 1000. Flip and multiply. Cancel, you just end up getting 1000. Okay? So the final answer for this guy is just 1000. So this is what I mean when I say make sure that you're actually looking at the answer scheme and then look at the question and see what manipulations you can and can't do. Because when you're doing the questions, it isn't just enough to be able to understand it. You need to find optimal ways to go about doing it. So to wrap up, what I would strongly suggest you do is every single question you do in mathematics, no matter how easy or how hard it is, I want you to see if you can find a more optimal method to go about calculating it. If you notice that a lot of questions that you take a long time to solve are really numerical questions, maybe it'll be a good idea to go out of your way to look for resources that help you calculate those numeric questions a little bit quicker. If you find yourself struggling to approximate correctly, maybe analyze those questions specifically and look at exactly why you messed up those approximations. Was it the fact that you scaled by a factor of 10 when you shouldn't have? Was it the fact that you scaled by a factor of a couple cents or a couple decimal points when you were able to actually scale up further, right? What actually made you take a long time to do a question, and how can you go about solving it a bit quicker? A lot of people say aim for 30 seconds a question. My advice to you, if you really want to get in and you really want to put your best foot forward in the exam, is aim for 20 seconds a question, or less than 20 seconds a question. Because a lot of the questions that you can do in the exam are really numeric based. Of course, there are going to be some questions that take much, much longer. You need to be smart enough to create your own flags and go, oh, this question is going to take me a while because I know I need to do this step, and this step, so I'm going to skip it. And you should be able to recognize that within a couple seconds. So hopefully this guide helped you out a little bit. If you haven't already seen the science reasoning guide, there's another one that I've made. It'll be up on screen or in the description as well. But other than that, don't like, don't comment, don't sub. Log off and do something else now. See ya.